So I would like to tell you about what we can learn from Earth's history. The environmental conditions on Earth are rapidly changing. The climate is changing, but associated with that, the oceans are becoming more acidic and are losing some of their oxygen. There's a general loss of biodiversity, and then there are all sorts of local and regional problems, like in the Netherlands we are dealing with the so-called nitrogen crisis, or stikstofcrisis in Dutch. And as with any crisis or period of change, we can learn a lot from history, right? We study our human history and we teach it in every school because having some sort of historical perspective on things can help us make sense of the times we live in. And we sort of saw that again as well with this pandemic. As while we faced many new and unfamiliar challenges, we also have had pandemics in the past that we have studied and learned from, and they've helped us to better deal with this crisis. Now, in a similar way, we can think about Earth's history. Right? We can study past intervals of environmental change, learn from them, and they can help us to better deal with the ongoing environmental crises. However, the problem with Earth's history is that the timescales involved are way beyond what we generally tend to think about. I'll give you one example. This year, the concentration of CO2 in our atmosphere reached a value of 420 parts per million. And this is an important number in many ways because it sets the environment and climate that we live in. Right? It will affect how often we will see floods like we saw last summer and how severe they may be. It will determine how hot our summers are going to get. And ultimately, this will determine if we can keep our feet dry and protect ourselves from the rising sea levels. So it is an important number to get some sort of historical perspective on. The problem is that since we have started measuring CO2 concentrations around 1960, they have only gone up. Right? So year on year, we see higher concentrations of CO2 than the year before, such that we are now really in unprecedented territory. What we can do, though, is we can go back further in the past by studying indirect records. For example, we can study little bubbles of air trapped deep in ice cores, and they can tell us about the concentration of CO2 for the last hundreds of thousands of years. Even further back, we rely on the history or the record of sedimentary rocks that are slowly over time deposited on the seafloor and can give us some sort of indirect sense of the climate and environment at the time. And those studies suggest that we'd have to go back at least 2 million years before concentrations of CO2 were last as high as today. And now this is sort of a unit that we don't really understand anymore, right? We can sort of maybe imagine what 1,000 years means, but millions of years is beyond our general sense of time or way of thinking. So what I'd like to do with you today is I would like to discuss Earth's history and highlight a few things that I think may be relevant for our current environmental crises. But I'd like to do so on the timescale of 1 year, a timescale that we all know and understand. So essentially, I've been so kind to you all to squish all of Earth's history into 1 year, and we'll discuss relevant changes as they come up, recalculated on this timescale. Or in other words, Earth's formation 4.5 billion years ago is set on the 1st of January, and we are now at midnight on New Year's Eve, the 31st of December. So, as I said, it all started about 4.5 billion years ago when some rocky bits were flying around a young star, our sun, and they started to collide and pack together to form the Earth. Now, the early Earth was a rather inhospitable place. The crust was still forming, so you get these liquid rocks or magma on the surface of the Earth. There was no oxygen yet in our atmosphere, and then the Earth was constantly being bombarded by bits of rocks and ice that were flying around in our solar system. However, as things sort of calm down a bit and the Earth cools down, it turns out that it's just about the right distance from the sun to allow an ocean of liquid water to form. And somewhere in this ocean, life develops. More and more complex molecules start to form, and they start to link together in ways that essentially at some point we decide to call life. Now, this life develops fairly early on in Earth's history, but it wouldn't really look like anything we can recognize as life with our own eyes. And it would take a very long time until it starts to do so. A key step in that development comes almost 2 billion years after life first appears, or on our timescale today around the start of summer. And this is when oxygen permanently becomes part of our atmosphere. It's a great example of how life starts to shape the Earth's environment, and not just the other way around. Us humans are certainly an example of this as well, but one I'll discuss later. In this case, these are photosynthetic organisms that produce oxygen as part of their metabolism and thereby ultimately change the composition of our atmosphere. It would take almost another 2 billion years, though, before oxygen to reach near modern levels, or before life really kicks off. In the meantime, life sort of slowly develops. We go from this simple single-celled life to multicellular life. We see the origin of sexual reproduction, and then the Earth goes in and out of this so-called snowball Earth state a couple of times. Extreme ice ages where almost all of the Earth was covered in snow and ice. Life, however, makes it through this, but remains relatively small until around the start of the Cambrian period. And this is when life really kicks off. It starts to resemble things we can actually recognize as life. And from here on out, life develops into all sorts of different shapes and sizes. Life moves from the ocean to land, conquers land, forests start to grow, and essentially from here on out, we are on track to develop towards more modern life. However, this development wasn't always straightforward, and there were some major extinction events in Earth's history. The biggest of them all occurs around the Permian-Triassic boundary. Large-scale volcanism pumps a lot of CO2 up into the atmosphere, and this changes the Earth's climate and environment in such a way that many organisms wouldn't survive. It leads to ocean deoxygenation, so the loss of oxygen from the oceans. It leads to ocean acidification, and it leads to global warming. 3 things we actually also see happening today. And it's this triple threat of environmental change that's too much, especially for many marine organisms, and the large majority of them go extinct. However, as always, there is opportunity in adversity, and in this case, there was an opportunity for the dinosaurs to take over. It takes the Earth a few million years to recover after this extinction event, but then the first dinosaurs start to appear, and after another major extinction event, they would start to dominate the surface of the Earth, and would do so for the next 130 million years or so. However, as you know, also dinosaurs go extinct at one point, and in this case, they had particularly a lousy holiday season, as on Boxing Day, a big asteroid hits the Earth and wipes them out. Now, if we compare those 2 extinction events, right, a big asteroid hitting the Earth versus this large-scale volcanism, are 2 very different causes. But it turns out that if you compare these and other extinction events, what they tend to have in common is the rate of change, right? So it's not so much about the causes or even the magnitude of change as it is about how fast things are changing. Something to keep in mind for our current conditions. With the dinosaurs gone, it was time for mammals to take over. And they start out small originally, but now have space to quickly grow larger and larger in size. Essentially, from here on out, mammals develop into the mammals that we know them. Humans, however, don't appear until the very last day of Earth's history, or actually the very last half an hour or so. Humans are thought to, or Homo sapiens are thought to originate in Africa around 200,000 to 300,000 years ago. And for much of their life, they lived a sort of hunter-gatherer lifestyle, right? They move around as nomads and live off the food they find around them. And as the Earth goes in and out of ice ages, Homo sapiens slowly start to spread to other continents and around the globe. It's not until after this very last ice age, about 9,000 years ago, or the very last minute of this year of Earth's history, that humans start to settle down. They learn to grow their own food rather than to chase it down, or in other words, we see the invention of agriculture. And this had a major impact on the life of humans because it allowed them to settle in one place. They could live in larger and larger groups, build cities, build societies, etc., etc. Fast forward to 1870, about 150 years ago. A guy named John D. Rockefeller in the US starts the Standard Oil Company, and it would soon grow out to be the biggest company in the world. 1870 also marks the start of the second industrial revolution, or the very last second of this year of Earth's history. And in this last second, in these last 150 years, really a lot has changed, right? We have built entire cities and created all sorts of wonderful art and technology. We have doubled our life expectancy, and the human population is now 5 times as big as what it was only 150 years ago. And a lot of this was made possible because of fossil fuel exploitation, right? We had this cheap, reliable source of energy taken out of the ground by Mr. Rockefeller and all his later colleagues. That has brought a lot of prosperity to many people and fueled technological advancements that otherwise would not have been possible. However, as a side effect, it also changed the composition of our atmosphere. CO2 concentrations rose by about 130 parts per million, or about 40%, and we are now starting to see the adverse effects of this on our climate and environment, for example, in the form of more extreme weather events. In these last 150 years, we have changed the Earth's climate in such a way that will last for many, many thousands of years into the future. However, eventually the Earth will recover, and all of this will turn out to be sort of a minor blip in Earth's long history. Consider it something like a bad flu for the Earth or something. Any sort of climate policy, therefore, is not so much about saving the Earth as it is in our own interest. Right? We are currently rapidly changing the very environmental conditions that have allowed humans to thrive and flourish. So naturally, changing those conditions will have a negative impact on the large majority of people. Exactly what the consequences will be to us and our lives and those of future generations is unclear, as a lot depends on our actions in the next few decades, as well as on our ability to adapt to changes. What is clear, though, from Earth's history is how incredibly fast we are currently changing the Earth's environment, and that such fast changes always had a negative impact on Earth's inhabitants. So here we are then, the result of over 4 billion years of the evolution of life on this planet. We've gone from simple single-celled life to multicellular life to dinosaurs and to us humans and everything else that we see around us. Perhaps the biggest difference between us and all those other life forms is that we can actually study the past and reflect upon it. But also we can look forward and envision a future. It is up to us then to decide what we actually want that future to look like. Which brings me to the present and therefore to the end of this year of Earth's history. A time for reflection, but also, a time to look ahead, a time perhaps for New Year's resolutions. If I may be so bold to suggest one for all of us, it will be to rapidly decarbonize our economy. Thank you very much.